California's coastline is facing an unprecedented challenge. Massive waves are slamming into beaches and infrastructure, prompting urgent warnings from scientists and emergency agencies. This isn't just a typical winter storm. Ocean dynamics and powerful offshore systems are combining to amplify these waves to dangerous levels. We'll break down what's driving this surge, highlight high-risk areas, and explain critical threats to our coastal environment. Understanding these forces is crucial as conditions could intensify. Right now, coastal communities from northern to southern California are experiencing the brunt of this powerful wave activity. Beaches are closed, piers are being damaged, and coastal roads face inundation. Inundation means being covered with water. Emergency crews are on high alert, monitoring the situation moment by moment. Authorities urge residents and visitors to stay away from the shoreline, emphasizing immediate dangers. The sheer scale of these waves demands attention and a clear understanding of their origins. What's generating these colossal waves? The primary cause lies hundreds, sometimes thousands, of miles offshore, powerful storm systems. These aren't necessarily storms directly hitting California, but vast, low-pressure areas churning over the open ocean, acting like giant wave factories. As strong winds blow across the water surface for extended periods and over long distances, what we call fetch, they transfer enormous energy. This energy builds into the swell that travels towards our coast. Let's clarify a key term: swell. Swell refers to ocean waves that have traveled away from their generation area. Unlike choppy local wind waves, swell is organized, looking like smooth, rolling lines. Wave period is another crucial factor, meaning the time for two consecutive wave crests to pass a fixed point. Longer wave periods indicate more powerful waves with deeper energy. This event features unusually long period swells, allowing immense energy to be unleashed upon the coast. Beyond offshore storms, local ocean dynamics significantly amplify these waves. One critical factor is the bathymetry, the underwater topography, or shape of the ocean floor. As deep water swells approach a shallower coastline, they interact with the seabed. This causes waves to slow, wavelengths to shorten, and height to increase dramatically. It's like an underwater ramp, forcing wave energy upward. Certain features can focus wave energy onto specific coastal parts, creating exceptionally large and dangerous surf zones. While large waves are dramatic, they're compounded by a storm surge. This isn't just a giant wave, it's an abnormal rise in water level above the predicted tide. It's caused by strong winds pushing water onshore and by the low atmospheric pressure of a storm. Imagine a giant hand pushing water towards the coast. This elevated water allows powerful waves to reach much further inland than normal, causing extensive flooding and property damage in areas usually safe. This current storm surge in California is particularly concerning due to multiple amplification factors. Powerful offshore swells are coinciding with higher than average tides, meaning the baseline water level is already elevated when massive waves arrive. Furthermore, coastal currents and local wind patterns contribute to the onshore push. These synergistic conditions create a perfect storm, where the combined effect is far greater than the sum of its parts, resulting in the destructive power we're witnessing. Which areas face the highest risk? Low-lying coastal areas, barrier islands, and sections with historical erosion are most vulnerable. In California, this includes certain stretches of beaches in Santa Cruz, specific communities along the Orange County coast, and parts of the Northern California shore. Harbors and marinas, especially those with narrow entrances, are also at high risk due to wave refraction and reflection. Emergency officials issue evacuation orders and warnings for these specific zones, urging immediate compliance. Scientists and emergency agencies rely on sophisticated real-time data to monitor these conditions. This includes networks of offshore buoys measuring wave height, period, and direction. Tide gauges continuously record water levels. Satellite imagery provides overviews of ocean conditions and storm systems. Advanced computer models use this data to predict wave propagation, surge heights, and potential inundation areas. This critical information allows for timely warnings and helps authorities make informed decisions to protect lives and property. One insidious and long-lasting threat from these massive waves and storm surges is coastal erosion. Coastal erosion is where waves and currents gradually wear away land along the shoreline. Powerful waves scour sand from beaches, undercut cliffs, and wash away protective dunes at an accelerated rate. This not only reduces beach access but threatens homes, roads, and utilities built too close to the edge. The land itself is literally being eaten away, fundamentally altering the landscape. California's vital ports and harbors face significant dangers. These gateways for trade and commerce, handling cargo ships and fishing fleets, can suffer damage to breakwaters, jetties, and docks. Breakwaters are structures protecting harbors from waves. Intense currents generated by the surge make navigation hazardous, potentially leading to collisions. Furthermore, debris carried by floodwaters can clog channels, disrupting shipping operations and incurring substantial economic costs. Our beloved beaches, crucial for recreation and tourism, are under immense threat. Beyond immediate danger, these waves cause significant physical changes. Lifeguard towers can be swept away, beach access points destroyed, and fragile ecosystems severely disrupted. Sand dunes, acting as natural barriers, are particularly vulnerable. Loss of sand can expose underlying rock formations, permanently altering a beach's character. Restoring these environments often requires extensive time, effort, and financial resources. Dangers extend far beyond the immediate coastline. Critical infrastructure, including coastal roads, railway lines, and essential utilities like power lines and sewage systems, are highly vulnerable. Flooding from storm surge can wash out roadbeds, undermine rail tracks, and short-circuit electrical systems. Repairing this infrastructure is costly and can cut off essential services and transportation for days or weeks. It's a reminder of how interconnected our infrastructure is and how a single event can trigger widespread disruption. Experts warn these conditions could worsen. Leading oceanographers and climate scientists closely monitor the situation, cautioning that current weather patterns, potentially influenced by larger climate trends, create an environment where extreme wave events are becoming more frequent and intense. Intenser means more powerful. This isn't just a one-off event, it's part of a broader pattern requiring long-term coastal resilience strategies. The future of our coastlines depends on our ability to adapt. How do broader weather patterns and climate influence these waves? While individual storms are complex, scientists suggest a changing climate can contribute to more energetic ocean conditions. Warmer ocean temperatures can provide more fuel for intense offshore storms. Global sea level rise means the baseline water level is higher, allowing waves to cause greater damage further inland. This intertwining of local weather, ocean dynamics, and long-term climate change paints a challenging picture for coastal communities. Given these urgent warnings, what should residents and visitors do? First, always heed official evacuation orders and warnings from local authorities. Staying informed through reliable local news is vital. Avoid coastal areas, beaches, and piers during storm surge and high wave events. Even observing from a distance can be dangerous. Never turn your back on the ocean. If you live in a low-lying area, prepare an emergency kit and have an evacuation plan ready. Safety must be your top priority. Looking ahead, coastal communities are exploring long-term strategies for coastal resilience. This term refers to a community's ability to withstand, recover from, and adapt to hazards like extreme waves and sea level rise. Solutions range from natural approaches, like restoring protective dunes and wetlands, to engineered solutions, such as stronger sea walls and elevated infrastructure. It also involves smarter land use planning, limiting construction in vulnerable areas. These proactive measures are essential to safeguard our coastlines for generations. The economic toll of massive wave events and storm surges is substantial. Damage to homes, businesses, and public infrastructure can amount to hundreds of millions, even billions, of dollars. Economic toll refers to the financial cost. Tourism, a vital industry, suffers immensely from beach closures and damage. Fisheries can be disrupted by hazardous conditions and damage to ports. The ripple effect extends to insurance markets and local economies, highlighting the urgent need for investment in protective measures. How does this current event compare to past California storms? While California is no stranger to powerful winter waves, scientists note the unusual combination of extremely long-period swells and significant storm surge. Historical data reveals powerful events, but frequency and intensity appear to be increasing. It's not always about record wave heights, but rather the cumulative impact and broader reach due to elevated sea levels. This makes current events a critical benchmark for future coastal planning and emergency response. The huge waves rocking California serve as a powerful, immediate reminder of our vulnerability to ocean forces. Scientists' urgent warnings underscore the need for both immediate response and long-term planning. Protecting lives, critical infrastructure, and our natural coastal beauty demands a coordinated effort from communities, governments, and scientific institutions. Understanding the complex interplay of offshore storms, ocean dynamics, and a changing climate is the first step. Urgent action today determines the resilience of California's precious coastline for generations.